How is perception organized? Well, whenever we look at anything, we need to make inferences. So one of the things that we can do is take into account depth. And depth allows us to get an idea of how far away something is, how close something is, and just it adds to our perception of objects. And so in order for us to take into account depth of objects, we can use a few different tricks. So the first thing that we can immediately notice is that humans have two eyes. So we have binocular vision. And binocular vision basically gives us something known as retinal disparity. Retinal disparity. So basically, since our eyes are about 2.5 inches apart, and this basically allows us to get slightly different views of objects in the world around us. So for example, let's imagine you're at a bowling alley. When you're looking at some pins, your left eye sees the bowling pins in this angle, and your right eye sees them in this angle, and your brain takes these two images, puts them together, and gives you this image over here. And this gives us some degree of depth of what we're looking at. So that's retinal disparity. So another way that our two eyes help us take depth into account is something known as convergence. And this basically is trying to say that when we're looking at things really far away, the muscles in our eyes are fairly relaxed. And when we're looking at something really close to us, the muscles in our eyes turn our eyeballs towards the object. And so our brain is able to look at how much the eyeballs are turned in order to give us another kind of depth cue. So there are other cues that we can get that we don't need two eyes for. So those would be monocular cues. Monocular cues. And one monocular cue would be relative size. Relative size. So relative size gives us an idea of the form of an object. So perceptual organization is organized into depth and then form. So relative size would be, let me just bring up a few examples. So relative size would be this example over here where we've got two ants and this ant is perceived to be bigger. And since it's perceived to be bigger, we know ants are fairly the same size. So since this ant is perceived to be bigger, we perceive it as being closer to us. Even though we know these two ants in real life are the same size, but since this guy is bigger, we think of it as being closer to us. This we really only need one eye for. We can see the relative size of things and infer the proximity of the object to us with just one eye. Another monocular cue is something known as interposition. So interposition would be this example over here, where you only need one eye to see that this rectangle is in front of this oval. And we can infer that since the rectangle is in front of the oval, that the rectangle is closer to us. Another monocular cue is relative height. Relative height. So relative height would be this example over here. Relative height is basically saying that objects that are perceived to be higher are perceived to be further away than those that are lower. So this rectangle over here, this one over here, is higher up than this red rectangle over here. And so because it's higher, and based on all the surrounding cues, we perceive it to be as further away. But in fact, they are the same exact shape. They're the same exact height. It's just that this one is placed physically higher than the red rectangle, and so we perceive it to be further away. So that's relative height, and that's a monocular cue. And one more monocular cue is shading and contours. So we can actually use light and shadows in order to get an idea of the form of an object. So these two images over here are actually the same exact image, it's just that this one is flipped over. So we took this image, we flipped it upside down, and now we see it over here. So in this image, we kind of see this little contour. It looks like a crater. Whereas over here, it looks more like a volcano-y mountain. So based on light and shadow and the shadows of an object, you can kind of infer whether it's a crater or if it's coming out of the earth like this. So these are some monocular cues. So those are the monocular cues that we can use to get information about the form of an object. There is another degree to perceptual organization, and that is motion. So whenever we perceive an object, we have to categorize whether it's moving or not. And so there's one interesting monocular cue known as motion parallax. Motion parallax, or relative motion. And what this is basically saying is that when you're in a car and you're driving around, the things that are closest to you appear like they're moving really, really quickly, whereas things further away from you appear like they're moving really slow. So if you've ever driven down in a desert or something and looked off in the distance and seen mountains, you're looking at mountains, the mountains look like they're moving really, really slowly, whereas things like cars right next to you or the road looks like it's moving really quickly. And so that is relative motion, and that's a monocular cue. You can get an idea of how far away things are based on how much they move as you move. And one other perceptual category is constancy. And there are a few different types of constancy. So there is size constancy. So over here we have size constancy. So when we look at these two ladies over here, we can see that this lady is bigger than this one over here. So this lady casts a bigger image on our retina than this one does. Yet we know that these two women are more or less fairly the same size. So even though this woman casts a bigger retinal image than this one does, we know that they're fairly the same size. So that's size constancy. There's something known as shape constancy. So shape constancy would be over here. So here we have a door, it's a rectangle, and as someone is opening the door, the shape that we actually see changes a little bit. So if we actually look at it, it's no longer a rectangle, it's more of this trapezoid. So it's actually changing in shape. So the image that the door casts on our retina is actually different. Yet we know that the door isn't changing shape, it's still a rectangle, it's just that it's getting opened, so our perception of the door remains the same. We know it's the same shape, even though it's casting a different image on our retina. And one other type of constancy is color constancy. So color constancy. So here we have a red cup, and despite changes in the lighting, we know, even though over here this red appears to be brighter than this red over here, this part of the cup looks darker, even though the actual color that is falling on our retina is different, we know that the cup is actually the same color. So that is color constancy.